Good day, everyone. So for the applications of angles, this is for week 2, day 2. For the application of angles, actually, we do have three subtopics here. So the first one is the angle of elevation. The second is the angle of depression. And then the third one is on bearing. For the angle of depression, angle of elevation, so you can see here on the screen. Okay. So in the screen, so you can see here the ship. So you can see here the ship, and then we do have here the lighthouse, and then the angle of elevation. Okay, the angle of elevation, as what you can see on the screen, we do have here this angle of elevation, which is the angle for this right triangle. Okay, this right triangle on the lower portion. So just remember that for the angle of elevation, so this side of the triangle, this is actually the horizontal. This is one part or one side of the right triangle. Remember, when it comes to applications, especially if the topic is, well, so just like our topic that well, it is on angles, so we also discuss the Pythagorean, trigonometric functions. Your aim is always to come up with a right triangle in the problem. So with the said right triangle and considering the angle of elevation here, so you can see we really do have here a right triangle, okay, on this portion, the lower part. And with the horizontal, so this, well, this side of the triangle, we also have here a perpendicular. So the perpendicular side of the right triangle is actually the vertical. So what is the vertical line? So it is a line, okay? It is a line from this point and towards, okay, towards the horizontal, so that you can be able to form a right triangle. You can therefore form a right, well, so a right triangle, a right angle here. And the said right triangle, well, so we have here another side here, okay? So since we do have a right triangle, so how can you have this side? It is actually the what we call as the sight line. So how can you have a sight line? So for example, you are in a ship, and then currently you are looking at the, well, you are currently looking at the top of the lighthouse. So you can actually form a line there. So with you, okay, currently looking at the top of the lighthouse, or you can see the top of the lighthouse, there is actually a line, a straight line that can be formed, and that is the sight line. Okay, again, so we do have here the sight line. Okay, if you are looking, if you are at the ship, then you're currently, well, looking at the top of the lighthouse. We have the horizontal. Okay, so you would notice that the horizontal is actually beside the angle of elevation. Okay, and then the angle of elevation is actually, it is where you are. For example, if you're in the ship, so it is where you are. And then the perpendicular is actually from the object or the thing that you can see, okay, towards the horizontal. That's it. For the angle of depression, so say that for this one, say that you are on the top of the lighthouse, and then you are, well, you can see a ship, okay? You can see a ship. So if that is the case, also we do have the sight line or the line of sight. Then same as with the angle of elevation, you should have horizontal, the horizontal line. Okay? So if this is the horizontal line and then we have the sight line, so in between you have the angle of depression. If you would try to notice, the angle of depression is beside the horizontal, and also it is, well, you can see that it is near you if you are at the top of the lighthouse. Next, so to complete the right triangle, again, we need the perpendicular or the vertical line. The vertical line is from the thing or object that you can see towards the horizontal so that you can form the right angle, the right triangle. Okay? So we do have separate discussions on these two angles on the following, on the next slides. So for the angle of elevation, as what I was saying a while ago, so just like if you are in a ship, okay, and then you are looking at the top of the tower, or you can see the top of the tower, so the tendency is you're gonna look upward, okay, you're gonna look upward. So if this is you, okay, the red dot, the black dot here, okay, the black dot, if this is you and you are, well, you can see an object that is above you, so you have the sight line, okay? Just like if you are, well, say that you can see the clouds, okay? So of course the clouds are above you. So from you and then seeing the clouds, so there's the sight line. Next, we do have the horizontal, okay? The horizontal here is actually the normal position of your face or your head, or even your eyes. So if you try to look at something that is above you, the tendency is you're gonna look up, okay? So your head will actually move upward, okay? It will actually move upward. And then if not possible, your head can be in normal position, but then your eyes can actually look up, okay? So from the normal position and then looking at something, that is when the angle of elevation is formed, or when can you have the angle of elevation. And remember, your aim is to come up with a right triangle, okay? So for this to become a right triangle, remember, you need to have a perpendicular line or vertical line. The vertical line or perpendicular line is actually, well, it is actually from the object, again, it is from the object towards the horizontal. So that you can form a right angle, you do have a right triangle. So this is the perpendicular, okay? And then, in order to apply the Pythagorean and trigonometric functions in the angle of elevation, so since we do have right triangle already here, you have to identify, so the opposite, adjacent, and then the hypotenuse sides. Since we have the angle of elevation, so this means that this is our theta. Okay, so labeling which one is the opposite. So if this is the theta, the angle, so the side opposite it is the perpendicular. Okay, and then the side that is beside it is the horizontal, which is the adjacent, and then the side which is the longest is the what? The sight line. So it is the hypotenuse. So our right triangle is complete. We do have the angle. We do have here the opposite, which is the perpendicular. We have the adjacent, which is the horizontal because it is beside the angle. And then the longest side is the hypotenuse. Okay? This is the hypotenuse also because the sight line is opposite the right angle. Okay, next. Angle of depression. For the angle of depression, this is when you're looking at something that is below you. Okay? So if this is you and then the object is below you, say that you are looking, well, say that you are looking at the sandals of your brother or your sister, or you can see a toy on the floor. You can see what? You can see, for example, in the classroom, if ever that you can see the shoes of your classmates, okay? And then you're gonna say now, wow, your shoes are shiny and black, okay? So there is the angle of depression. So in the angle of depression, so we have the sight line. So while you are looking at an object that is below you, and then the same horizontal. The horizontal is again the normal position of your face. So if you are looking down, okay, so if you're gonna look down from horizontal, the normal position of your face, looking at something that is below you, so the angle of depression is formed. Okay, so we do have the angle of depression. Again, remember your aim is to come up with the right triangle. So with the right triangle, you should have the opposite, adjacent, and then the hypotenuse. Okay? So with this, what you need to do is to first complete the right triangle. So from the object, you're gonna draw a perpendicular line, okay, vertical line towards the horizontal so that you can form the right angle. Therefore, you can have a right triangle. Okay, now let us label this. So if our angle of depression is here, which is our theta, so this means that the opposite side in the right triangle here, okay, the opposite side is the perpendicular, somehow the same as the angle of elevation. And then the side that is beside the angle of depression is the horizontal. So this will be the adjacent. And then the longest side, which is opposite the 90-degree angle, is the hypotenuse. Okay? So that's it. Now, let us go to the problem solving. So in the problem, it is said that from the top of a lighthouse, 50 meters in height, the angle of depression of the ship on the water is 16 degrees and 20 minutes. How far is the ship from the base of the lighthouse? Okay, so if we're gonna draw or we're gonna create an illustration of this, so you can see that in the problem, there is a lighthouse. So the lighthouse is 50 meters in height. So just to try to think of it, of course, the lighthouse is what? Standing. So your aim again in the problem is to come up with the right triangle. Okay? So we already have here the lighthouse. The lighthouse is standing. Okay? So you can draw it as a line. If you want to draw the lighthouse, so it is up to you. But then again, your goal is to come up with the right triangle. Okay, so say that this is the lighthouse. So this is the lighthouse. Then it is said that the lighthouse is 50 meters in height. Okay, next. So in the problem, it was mentioned that from the top of the lighthouse, the angle of depression. So of course, in our discussion a while ago, the angle of elevation is on the lower portion. Okay, the angle of elevation is in the lower portion. The angle of depression is in the upper portion. Okay, so angle of depression from the top. So it means that you're gonna draw, okay, a line here, and you need to, well, you need to include the 16 degrees 20 minutes in the illustration because that is the angle. So remember, to form the angle, you should have the horizontal. Okay, so this is the horizontal. So the angle here, it measures 16 degrees and 20 minutes. Okay, and then that is of the ship. So of course, the ship is what? It is actually below. Okay, this is the ship. I'll just move it a little. So this is the ship, okay? And then in the problem, so how far is the ship from the base of the tower? So what is being asked here is actually what? The distance of the ship from the base of the tower. This is the unknown x. Okay? You can see in our illustration that we already have a right triangle here. But then of course, our angle is on the upper portion, which is the angle of depression. So it is up to you which triangle would you like to consider. But then if you have the angle in this portion, so possible you can you can just complete the triangle on the upper portion. Okay? So in order to complete the triangle on the upper portion, we need the perpendicular in this side. So the perpendicular again is from the object that you can see, okay, towards the horizontal so that you can form the right angle, the right triangle. Okay, so this is the right triangle that we can consider. Okay, this is the right triangle. But then of course, you need to complete the sides. So this vertical, if you would notice, this is somehow the same as this 50. Okay, this is gonna have the same measurement. So this is also 50 meters. They are parallel, and then knowing that we do have horizontal here and also horizontal on the lower portion. So somehow we can form here a rectangle. Okay, if ever that the horizontal will also be 50, it means that we have a square. But then we are not sure yet because we need to determine the measurement of x. Okay, so the lighthouse height is the same as the measurement of this perpendicular. Okay, then the horizontal is somehow the same as the x. So this will also be our x. That's it. Now, I'll switch to the black screen. Okay, so we're gonna draw the right triangle. So remember, we have horizontal. So this is the horizontal. And then we do have the perpendicular. Perpendicular. And then remember that the horizontal is x. And then the perpendicular measures 50 meters based on our illustration. And then we do have here this side. Okay, this side is the sight line. This is actually the sight line. Then we're able to have here the right angle after we drew the perpendicular. Okay, then we have the angle of depression here, which measures 16 degrees and 20 minutes. Okay, now let us identify the sides. Remember that since our aim is to come up with the right triangle, so we already have it. The next thing that you need to do, you have to label which one is the opposite, the adjacent, and then the hypotenuse. Okay, so in the given, in our right triangle here, so since we have here the angle, 16 degrees and 20 minutes, the side that is opposite it is the 50. So this is our opposite. And then the side that is beside the 16 degrees and 20 minutes is the x. So this is our adjacent. And then the lighthouse is the hypotenuse. Okay? But then, even if we do have here the sight line, well, possible we cannot determine its side. First of all, it is not being asked in the problem. Okay? Second, we do not have any measurement here because it is not given in the problem. Okay? Again, the sight line, its measurement is not given in the problem, and also it is not asked in the problem. So if it is not being asked in the problem and possible, you can solve the triangle even without this hypotenuse. You can do it so. Okay. Now, since we are going to solve for the side x and given a theta, 16 degrees and 20 minutes, and then the opposite, which is 50 meters. So here we can use the trigonometric function. Okay, so what you need to do is just to think what trigonometric function can be used. So we have here opposite and adjacent. So opposite and adjacent, so opposite over adjacent. So this is actually the tangent theta. Next, you have to substitute. You have to substitute values or symbol based on this illustration of the right triangle. So this will become tangent. We have a value for the theta, which is 16 degrees and 20 minutes. We do have opposite, that is 50 meters, and then adjacent is denoted by x. Okay, now, since in the problem, what we need is x. Okay, so in our equation, we need to have a derived formula for x. Okay, so how are we going to do that? So you can do it by cross multiplication. Remember, we have equal sign, so we can cross multiply. If you know cross multiplication, the shortcut here is you can just, if you're given well, an equation like this, so the shortcut, you can just interchange the numerator, okay, the numerator tangent 16 degrees and 20 minutes, and the denominator x. You just interchange the two. If you do not know that shortcut, or you find it, well, you are not sure of it, um, you can do it step by step. So we have here tangent 16 degrees and 20 minutes equals to 50 meters over x. So the first thing that you need to do, since you need x to be the formula of x to be derived, in which we need to write the unknown on one side only without any other terms, okay? So what you can do is to multiply both sides by x. Okay, so in multiplying, so x times tangent, so we have x tangent, then write the angle 16 degrees and 20 minutes. And then equals x times 50, we have 50 m. You can put the x before the 50. So that is x times 50m divided by x. Now, you can already cancel. So on the right side, we can cancel the x, okay? And then you just write x tangent 16 degrees, 20 minutes equals to 50 meters, okay? After this, so I'll erase the upper portion. So after this, possible, I'll just write on the, well, on this side. Okay, you can divide both sides by 50, or rather by tangent, okay? You divide both sides by tangent. So we have here x tangent 16 degrees, 20 minutes equals to 50 meters. So dividing both sides, so we have here over 16 degrees and 20 minutes. And then you can already cancel, okay? So cancel the tangent 16 degrees and 20 minutes. Then we have x equals to 50 meters over tangent of 16 degrees and 20 minutes. So this will be the derived formula. Okay, that is the derived formula. Next, with your calculator, you can input 50 divided by tangent 16 degrees and 20 minutes. So the answer, so x, the answer is 170.62. Do not forget the unit meters. Okay? So let us just write the conclusion. Remember that when you compute, okay, when you compute using your calcu, you should remember that your calculator, okay, the calculator should be in degree mode. So the mode should be degree, okay? Because if it is not in degree, if it is in region, so possible you can have a different answer other than the 170.62. So be sure it is in degree mode, then input the 50 divided by tangent 16 degrees and 20 minutes. So your conclusion would be the distance, or we can say that the ship is what? The ship is 170.62 meters away from the base of the lighthouse. That's it. This can be your conclusion. Okay, next. So let us go back to the PowerPoint. For our next example, so a radar operator on a ship at sea detects an airplane that is 6,100 meters away and at an altitude of 1,100 meters. What is the angle of elevation from the ship to the plane? Okay, so let us draw this. So it is said that there is a ship, so with a radar, and the said radar detects an airplane. When it comes to the illustration, if you would like the ship to be on the right side, you can do it. Then having the airplane on the left. Okay, so the airplane is 6,100 meters away. Just for the for the distance, this is the horizontal. Okay, this is the horizontal. Take note. So distance we have, okay, we have 6,100 meters. And then, so this is the horizontal. And then it is said that the airplane has an altitude of 1,100. Okay, so from the object, okay, perpendicular line towards the horizontal. So this line is the altitude, which is 1,100 meters. So this is our perpendicular. Next, so since we already have our perpendicular line towards the horizontal, so we now hear the right angle. Okay, we now have the right triangle. So this is the sight line. Okay, what is the question? What is the angle of elevation from the ship to the plane? Okay, so since the radar, okay, is the one that detects the airplane, so in our illustration or in our discussion of the angle of elevation and depression, remember the U and the object? U and the object, the black dot. So this radar, this will serve as U. Okay, so this is the ship. This will serve as U. Because you detect the airplane. The airplane will become the object. Okay. So since this is you, remember that the angle of elevation, the angle of depression is always near you. So this is the theta. Okay. Now, let us solve this problem. So I will switch to the black screen. Okay. So let us draw the triangle. So again, so we have the sight line. So this is the sight line. Sight line. Then we have here the horizontal, which measures 6,100 meters. Then we have here the vertical or the perpendicular that measures 1,100 meters. Then we do have here the angle of elevation theta, which is being asked in the problem. Okay, now, since we already have here the right triangle, okay, what we need to identify now are the sides, okay? So what is 1,100 meters? Knowing that we have a theta here. So it is opposite the angle. Therefore, this is our opposite. 6,100 meters is beside the angle. Therefore, this is the adjacent. The sight line is opposite the 90-degree angle. So it is the hypotenuse. But then remember, the hypotenuse, the sight line is not given. It is not also being asked in the problem. So the opposite and adjacent are the only ones that we are going to use. So since we're asked of the theta, so it is obvious that we're going to make use of the trigonometric function. Because remember, the Pythagorean theorem is only used if we are considering sides. It means that you have two given sides and then one side is unknown. But then if there's already theta, so we're gonna use the trigonometric functions. Okay. In the trigonometric functions, you're just gonna think what function will consider the opposite and then the adjacent. Of course, that is tangent theta, because tangent theta is opposite over the adjacent. And then let us just substitute based on our illustration. So opposite is 1,100 meters and then the adjacent is 6,100 meters. We can already do the cancellation of the unit, meters, and then, or other meter, and then let us now derive, okay? Let us now derive the formula. So again, in order for us to derive the formula, the unknown, remember the unknown, should be left on one side only. Our unknown is the theta. So to have theta on one side only, so you just write the theta. And then since we do have tangent, so the tangent should be moved to the other side. It should be moved to the other side. Should be moved to the right, okay? So in order to do it, so if we have trigonometric, moving it to the other side, it means that we're gonna use the inverse. So moving tangent to the other side, it will become like this. Okay? So tangent raised to -1. By the way, we do not read it as tangent raised to -1. We read it as arc tangent or inverse. Inverse tangent or inverse tan. Okay, arc tangent. Let us just complete it. Inverse tangent. That's it. And then you're just gonna copy what is on the right side of the equation. So 1,100 over 6,100. Then this will be your derived formula. Okay, now use your calculator. So in your calculator, your answer would be 10.22 degrees. You can actually convert this to degree, minute, and second. So once you already have the 10.22 in your calculator, so be sure that you do have the complete decimal. Okay? So arc tangent, 1,100 over 6,100. So after having the result, you press the DMS. So after you press the DMS or this key, okay, so you're gonna have the answer of 10 degrees, 13 minutes, and 20 seconds. So this is just to show you the equivalent. Okay. So to answer the question, so let us have a conclusion here. The angle of elevation from the ship to the plane is 10.22 degrees or 10 degrees, 13 minutes, and 20 seconds. That's it. Okay? Next, I'll go back to the PowerPoint. So let us have now the bearing. For the bearing, so bearing is used in surveying and navigation. So directions can be given in terms of it. A bearing measures the acute angle that a path or line of sight makes with a fixed north or south line. The instrument that we use in measuring the bearing is the compass. Okay. So this is the mariner's compass. So we're familiar with how or on how a compass looks like. So we have the directions. Well, we have the north, the west, the south, and then the east. And then you can see in the in the compass. So it is somehow like a protractor, but then of course it is complete. Okay, with a complete revolution. Okay, from 0 up to 360 degrees. Okay, so this is an illustration of bearing. So what are the step-by-step, okay, procedure? So if we have here points A and B, so for say for example, we do have we do have points A and B. So this is our A, and then this is our B. So what is the first thing that you are going to do? So the first thing that you are going to do is to connect the 2 points. Okay, you have to connect the 2 points. Next, since here you can read to find the bearing of a point B from a point A. So the next thing that you are going to do, you have to draw the north. So in this step, draw the north of A. Okay. Possible you're gonna ask, how would I know if I'm gonna draw north on A or B? So you have to go back to the problem, or you are going to go back to the given. So in the given, it is said bearing of a point B from. So from A. So it means that you're gonna draw north on A. Okay, so we have here the north with the upward direction. Of course, north is upward. Next, um, after that, you're gonna measure the angle from the north, okay, in a clockwise direction, towards the line that connects the points. Okay, you have to determine the angle from the north in a clockwise direction towards the line that connects the points. Then you have to record the angle in degrees, and then record it as 3-digit figure. Okay. So when we say 3-digit figure, so for example here, this is more than 90. So say that it measures 100, say 105 degrees. 105 degrees is already 3-digit. Okay. If, for example only, if you measure the angle, say it is 78 degrees. So to record this as 3-digit, what you need to do is to add 0 before the number. So 0.78 degrees. Okay, then this will be your 3-digit figure of the bearing. Okay, next. So on the next slide, we have here an example. So there is a given diagram in which the bearing of A from B is 250 degrees. Okay. So as what you can see in our diagram, we again have here 2 points, A and then B. So according to the problem, there is a given bearing from B. So since we do have here the word from, so it means that we're gonna draw north. We're gonna draw north, okay, on the said point B, because it is said from B. So we have the north on B, so upward direction, and it has a measure of 250 degrees. So in this problem, what you can do is you put first a point, okay, you label this as B, and then you draw north on it, and then you measure the bearing. So from the north, clockwise direction, okay, clockwise direction, with your protractor, you have to measure 250 degrees. Once you measure 250 degrees, so you're gonna draw a straight line there, and then extending it, then put another point that will be your A. Okay? So possible you're gonna ask, Mom, why is it clockwise if the angle is positive? Well, we are talking of bearing. Okay, this is application. And just take note that it is always, well, it is positive, it is absolute. Okay, it is not like the angle in standard position, the angle in the Cartesian plane, in which if you have counterclockwise, you have positive angle. If you have clockwise direction, you have a negative angle. But for bearing, the bearing is measured in a clockwise direction. Okay, and recorded as 3-digit. Okay, now, so this is the given. What we need to determine is the bearing of B from A. So this time, what you're gonna do is, well, you also saw here, okay, you can read here the from A. So from A, it means that you're gonna have your north of A. So you need to have the upward direction, okay? And what is asked is bearing of B. So since here is B, then this is A, and you have to consider the from A, so that is the north. So it means that you need to what? You need to determine the angle from north. That is well, from north clockwise direction towards the line that connects A and B. So this will be your bearing. But then the question is, how can you find the measurement of this bearing? Okay, so you go back to the given. So there is a given 250 degrees. Okay, in this given 250 degrees, so you can actually determine the measurement of this angle here. Okay, this one. So remember when we discuss the kinds of angles, remember that if you are going to have a complete revolution here, okay, so this measures 360 degrees, okay? Therefore, it will be easier for you to know the measurement of this angle here. So that is 360 minus the given 250. The answer is 110 degrees. So this measures 110 degrees. Okay. But then how can you determine the angle here on A, angle or angles on A, if you have these angles on B, the 250 and 110? Okay. You have to remember the concept on alternate interior angles. Okay. In alternate interior angles, if you have here two lines, and then you have a diagonal, okay? So in alternate interior angles, if you have, for example, an angle R here, okay, opposite it will also be angle R. What does it mean? It means that both have the same measurement. Next, if you have an angle S here, same, opposite of it, you also have angle S. So you can apply this concept in our problem, okay, in this problem. So what you can do, you can try to complete the line, okay? So now, if you have north on the upper, you have south on the lower portion. So that is on A. Same with the B, okay? You just complete it. Next, so it is, well, you can easily see that we do have the two lines here. Then we have the diagonal. So we're going to apply this alternate interior angles. So since we do have 110 degrees here, opposite of it is also 110 degrees. Okay? Next, you try to remember the kinds of angles. The north-south, okay, from north going to south. So from the north going to south, you can measure the angle of this. This measures half revolution or half angle, the 180 degrees. Okay? So what does it mean? It means that you can already solve for the bearing. So this bearing, the unknown. So you can solve for this. So it means that 180 degrees minus 110 degrees, okay? So this is 70 degrees. So remember, in recording, you have to put 0 if you have 2-digit to make it 3-digit. Okay, so let us label our drawing. So the bearing is 70 degrees. Okay? Actually, to completely answer the question, so we can say that the bearing of B from A is 70 degrees. Okay? So that's it. The bearing of B from A is 70 degrees. Now, on the next slide, actually, you can see here the solution. But then in the previous slide, I already explained it. So draw the north line at A. Then the given is bearing of A from B, which is 250 degrees. And then we had the answer of 70 degrees. Next. So this is problem solving. In the problem solving, so a ship leaves a port at 1 p.m. and sails in the direction of north 24 degrees west at the rate of 10 kilometers per hour for 30 minutes. Then it sails north 66 degrees east for 1.2 hours. Find its distance and bearing from the port at 2:42 p.m. Okay, now so let us have the first sentence. Ship leaves a port. Okay? So the illustration for this problem is already provided. So the port is here. So this is the first point. Okay? So this is the first point. So leaves at 1 p.m. sails in the direction of north 24 degrees west. So it means that if we are going to graph this 24 degrees, the north 24 degrees west. So remember, so we have here north, west, south, and then east. So the north 24 degrees west, in order for you to graph this, you're gonna start at the north. You're gonna start at the north, and then it is said west. So it means that when you measure the angle, it is towards, okay, going to the west. So it is going to the west, you measure 24 degrees. Then you just draw a straight line, okay, and that will be your angle. So that is the reason why from this point, okay, we have here north, we have here south, we have here west, then we have here east. So from the north, 24 degrees going to the west was measured. And then you're gonna draw a straight line, okay, a straight line. Then this is another point. But then, of course, you have to determine what is the measurement of this line. So this line is actually the distance traveled by the ship. Okay? So remember that the speed of the ship is 10 kilometers per hour. And then, from the port going to this point, it only traveled half hour or 30 minutes. So it means that half of the 10 kilometers is 5 kilometers. That is the distance from the port going to this point. Next. So sails north 66 degrees east. So the same, you're gonna have, you can draw vertical and horizontal lines here, or you can have a cross. So north, and then we have here west, south, and then east. And then again, it is said north 66 degrees east. So from the north, you're gonna measure 66 degrees towards east. Okay? So from the north, going to east, you have to measure 66 degrees. And then after that, you're gonna draw a straight line. Okay, straight line. And then another point. Okay, another point. So from the second point going to the third point, you need to again determine what is the measurement. So in the problem, it is mentioned that the ship sailed for 1.2 hours with a speed of 10 kilometers per hour. So you just try to compute it. Of course, with 1 hour, we have 10 hours, okay? The ship sailed or traveled 10 kilometers. Again, so if we have 1 hour, so it means that 10 kilometers, okay, for the distance. So 10 kilometers, then 0.2 of an hour, so travel 2 hours, 2 kilometers, okay, 2 kilometers. So we have 10 kilometers plus 2 kilometers. So we have 12 kilometers here. Okay, next. So in the problem, find the distance and bearing from the port at 2:42 p.m. So find the distance, it means that you're gonna connect the last point and the first point. So connecting it, you have here a line, and then that line has a measure of x. So that is what you are going to solve or compute for. Then bearing from the port, so again we have here from. So you're gonna determine the bearing. So this is the port. And then since it has the from, so you're gonna have the north here. Okay? You're gonna have here the north. So from. So you'll have here the north. Okay? So from the north, going to the line that connects the port and the last point. So this alpha was used to denote the bearing. So that is the bearing. Okay. So what is the first step in solving this? So the first thing that you need to do is to solve first for the x. Since we have the measurement of the two sides of 5 and 12 kilometers, so you can solve for x. But then by the way, class, before you can apply the Pythagorean theorem or trigonometric function, even if you can see here a triangle, you need to be sure that this is right triangle. Okay, so how would you know that? So since we have here 66 degrees as the given, so you can have a measure of 24 degrees since you know that from north going to east, we have 90 degrees. Okay, 90 degrees. So that is 90 degrees minus 66 degrees, so we have 24 degrees. Okay, that is the measure of the angle in this, at this point. Okay, now. So we have, what else? So what are the other given here? Okay, now we have another 24 here, okay, as the given. So we have 66 and then 24, or 24 and then 66. So this 24 can be used. Remember the alternate interior angles? So you can see that we have two lines. So this line, okay, this line in black, and then this line also, okay? Then you can see the diagonal. So you can see here the diagonal. And if this measures, so diagonal, let us just make this like this. Okay, so you can see that if this measures 24 degrees, this would also mean it is also 24 degrees. Okay, so from the east going to the south, the angle is 90 degrees. So 90 degrees minus 24 degrees, we do have 66 degrees. So this is 66 degrees. And then just try to check if we can have here a right angle. So how would you know? So since we have here 24 and then 66, so adding the two, we have 90 degrees right angle, therefore we have a right triangle. So after after checking if we do have a right triangle, then you can already apply the Pythagorean theorem. In the Pythagorean theorem, so we do have two sides given and then one side unknown. So you can already solve it. So you can just, possible if you would like to use the opposite adjacent and then the hypotenuse. So since we have here an angle beta, so this can be the angle which you can use in determining the opposite. The opposite here is the 12 kilometers. The adjacent, which is beside the beta, is the 5 kilometers. So this is the adjacent. And then the unknown is the hypotenuse. So you apply the Pythagorean theorem. Okay, next. In the next slide, actually, you can see here the answer. So the distance from the last position of the ship, or rather the distance, okay, between the last position of the ship and the port is 13 kilometers. And then for the bearing, okay, for the bearing, since we are asked of the alpha here, okay, so what you can do is to solve first for the beta. Okay, so since again we have adjacent at 5, opposite at 12, and then hypotenuse at this x. So you can make use of this two, the opposite and the adjacent, to solve for the beta first. Okay, so for the beta, so beta is the angle. Okay, so we have opposite over the adjacent, so we have tangent beta. So substituting, tangent beta equals to 12 kilometers over 5 kilometers. So you can cancel the unit. And then we can have beta equals to, so since we only need the beta, so the tangent can be moved to the other side. It will become arctangent. So 12 over 5. Then just use your calculator. Okay, so beta, with your calculator, so that is arc tangent 12 over 5. So just be sure that your calculator is in degree mode. So it is 67.38 degrees. Next, since beta, okay, based on our drawing, it is 24 degrees plus the alpha. Okay, plus the alpha. So it means that the alpha is equal to beta minus 24 degrees. So substituting, so beta is 67.38 minus 24 degrees. So our alpha, so let us subtract. Our alpha is 43.38 degrees. Okay, so this is the value of alpha. But then since we need the bearing, okay, bearing, so bearing, the bearing is 0.43 degrees. Okay, this will be the answer. That is the bearing of the ship from the port. So the ship is here, and this is the port. So the bearing of the ship from the port is 43